Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course, Statistics 101, Introduction to Statistics. In less than 10 minutes, this video describes a general process for conducting a statistical study. Let's get started. Now, in the last lecture, we learned the difference between a population and a sample. With that difference in mind, let's look at the process for conducting a statistical study. Generally, all statistical studies have three main steps in common. These are preparation, analysis, and conclusions. By the way, which is larger, a population or a sample of that population? No, the pause was not a problem with the video. I'm intentionally giving a pause here so that you have the space and time to answer the question. These videos are designed for you to learn through interaction. So when I ask a question, go ahead and interact with it. And, you'll learn better if you speak out loud. So just go ahead and say the answer out loud. Which is larger, a population or a sample of that population? If you said population, you're right. A population is always bigger than a sample of that population. Let's now examine each of the three main steps in a statistical study in turn. So first up, you prepare by examining the context for your study. What measurements or data do you need to obtain, and what do they mean? Will the meaning change if you obtain them in a different way? And what exactly are you trying to achieve with your study? What question are you trying to answer? The answers to these essential questions will determine how you formulate your study. Now, I mentioned in the last lecture the difficulty in obtaining good data. That's why you always need to think about the data in every stage of a study. Initially, you want to ensure that your data are not biased. Many companies, groups, and movements frequently cite studies that they conducted which appear to support their own agenda. We'll look at some examples of this in future lectures, but this is one of the largest misuses of statistics out there. If for no other reason, taking this course is a great choice because it helps you see past the bias that abounds in our media-saturated world today. Now, we also need to consider our sampling method. In the last lecture, I mentioned that we want to ensure our sample is representative of our population so that we avoid faulty conclusions. One of the ways we do this is by using a sampling method that helps to ensure that. For example, have you ever visited a website only to be greeted by a pop-up window inviting you to take a survey? I'm sure many, if not all of us have. This is a sampling method known as voluntary response, and it typically introduces bias into the sample because those who respond have characteristics that motivate them to complete it, characteristics not shared by the whole population. That makes the sample less representative of the whole population and will lead to faulty conclusions if applied to the whole population, containing both those who will and won't respond to said surveys. Finding an alternative sampling method, and we'll talk about those throughout this course, will produce better results. Now, once you've prepared your study or experiment, then it's time to collect your data and analyze it. A typical approach involves making a visual representation of the data with some type of graph. Now, this step is really important because often the right graph can tell you what the next step of your analysis should be. In a world where time is money, you want to get to that next step sooner rather than later. We'll spend some considerable time talking about graphs in future lectures. We also want to apply statistical methods to our data. Often this will involve performing a hypothesis test or making a regression model. Those like me who learned to do this in the old school days had to perform a great deal of tedious calculations, so our computational skills had to be on par with the task. Today, there's an app for everything. And statistics is no exception. There's lots of software packages out there that will take your data and then tell you more than you ever wanted to know. But any numbskull monkey can push buttons on a computer. It takes common sense and a good knowledge of statistical methods to tell you what those results that the computer spits out actually mean. And it is at this point that we make conclusions from our study or experiment. Typically, we look for something called statistical significance, because that means our result is very unlikely to occur by random chance. Statistical significance becomes very important if you're trying to establish a relationship or association between two or more different variables. For example, perhaps you're a medical researcher studying cigarette smoking and ulcers in an attempt to investigate what, if any, relationship exists between the two. Whether one exists or not will be revealed by, among other things, whether or not you have achieved statistical significance in your study. Regardless of your results, however, you always want to declare the practical implications of your results. Many of those who are most interested in your results are decision makers within a company or an organization. They need to make a decision on and off and quickly, but they want to base it first on the results of your study or experiment. However, since many of these people aren't well versed in the language of statistics, you will need to express your results with all the statistics jargon out so others can understand them. So always state clearly the practical implications of your results. In this light, sound judgment, which includes a healthy dose of common sense, can go a long way. We see an example of that here. Someone decided to test the Atkins weight loss program on 40 subjects. After 1 year, the subjects in the study lost an average of 4.6 pounds. Now, performing a proper statistical analysis led to the conclusion that the average loss of 4.6 pounds is statistically significant. Do you remember what that means? What does it mean for results to be statistically significant? I'll give you a moment to respond. If you said it means the results are very unlikely to occur by random chance, then you're right. Here in this case, it means that the average weight loss of 4.6 pounds was very unlikely to occur randomly or by chance. Now, how many of you would sign up for a weight loss program where the average weight loss after 1 year was 4.6 pounds? I know I wouldn't. Although 4.6 pounds of weight loss is statistically significant, common sense says that result isn't practically significant. Any diet with those kind of results is clearly not very effective. So just because something is statistically significant does not mean it is practically significant. So you need to know statistics to get the end result, but you also need to use some common sense and good judgment in interpreting and determining the applicability of that end result. Are you starting to see how statistics is really a class in critical thinking? I hope so. And that brings us to the end of this mini lecture. Hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video. Howdy peeps, I'm Professor Curtis of Aspire Mountain Academy, and I hope you enjoyed this free sample mini lecture from my Stat 101 course. This is a course that I worked really hard to develop. It's taken me a while to get through it, and I hope you enjoyed this free lecture. If you want more like this, then you need to sign up for my Stats 101 course. So go to the link there in the description down below the video. If you like this video, go ahead and give it a like and subscribe to the YouTube channel, and I will see you in the next video.